If there is any issue with the noise, then please let me know. If you are not able to hear me in between the class, then please let me know. Okay. Okay, good. Thank you, Sanjeev. So we can start our class. So there is a second unit. I am sharing my presentation. Okay, my slide is visible to everyone. Yes, Sanjeev, just can you confirm me? My slide is visible to everyone. Yes, anybody? Sanjeev? Okay. Yeah. So in the previous class, we discussed the first unit. That is the analysis of the uh, non-linear magnetic circuit, then field energy theory. There is a field energy of the magnetic circuit and the principle of the energy conversion process. So how we can convert the energy from electrical energy into the magnetic energy and the magnetic energy into the electrical energy. So basically we have a two device. So we can say motor and the generator, and that is under the one umbrella, that is a machines, correct? So we can say machines, that is nothing but conversion of the energy from electrical to mechanical, otherwise the mechanical to electrical. Okay. So so last class we completed the first unit, that is like introduction of the our machines, correct? So today we can start with the DC machines, that is a unit number 2. Okay, that is a DC machines. So, lecture outcomes from the today's class. So, starting with the theory of the DC machine, there is a just review, overall review, then the model of the commutator. So, today we will discuss the two topic only. There is a fundamental of the DC machines and then model of the commutator. Okay. Yes. Somebody want to join the class? Just 1 minute. Yes. Okay. So before going to detail about the DC machines, so I would like to know about your knowledge regarding the DC machine. So starting from the Anis Sharma, are you there? Yes, Anis, are you there? Okay,
Yes,
Gyan?
yes, sir.
Yeah, yeah, Anis, yes. Can you just tell me about the DC machines?
Yes, sir. Sorry, sir.
Can you just tell me about the DC machine? What is a DC machines?
Electromechanical device
Okay, so what is the difference between
used
the
for the
AC and
energy
DC?
alternation.
Okay, good. But what is the difference between the AC machine and DC machines? Something like that. So DC
DC
machine,
machine
there
is
is a working on the.
BLDC motors.
Okay, correct. Okay, good. Yes, Jan, are you there?
Yes, sir.
Yeah. What is the difference between the AC and DC machines?
DC machine has a commutator, sir.
Mm-hmm.
But in AC machine, there is a splitter.
Okay.
Mm, That is main difference, sir.
Okay, good. Yes. So Gyan, is it possible we can operate the DC machine by the AC supply?
DC machine. mm,
Is it possible? Suppose we have a DC machines, and I can give the AC supply and motor is operate. Is it possible?
yes, sir. There is a commutator in DC machine, so
Okay. 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 Good. Yes, Indradev, are you there?
Yes, sir.
Yeah. So is it possible we can operate the DC machines by the AC supply?
Similar. Maybe, sir, possible because the commutator converts DC in AC into DC in unidirectional current, but in maybe, sir, not possible. Is conversion from AC to DC?
Okay. So what is your final answer? Yes, yeah, no.
No, sir.
No. Okay. Then what is the difference between the AC and DC?
Uh, in DC machine, the commutator converts the AC into unidirectional DC, but in AC machines, the supply is generally AC. And in DC machines, there is a permanent magnet or electromagnet.
Okay. 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 Good. Yes, Kishore Chandra, are you there? Yes, Kishore, are you there?
Yes, sir, I'm here.
Yeah. Good. Good. Yes. Any idea?
DC machine is not operated AC, sir, because DC machine DC voltage only supply.
Uh huh.
That's it, sir.
Okay. Good. Yes, Ravin. Ravin Saudin.
Yes,
Subedi.
sir.
Ravin
Yes,
Subedi.
sir. I am here, sir.
Yeah. Yes. So any additional part? So can you would like to add?
I think it can operate with AC, but there will be sparking uh, in the commutator and brushes.
Okay. Good. Yes, Sanjeev. What about you?
Yes, sir. I think it's we use commutator in DC machines. Commutator can rectify AC to DC or either DC to AC. I think it's possible, sir.
Okay. Yes, Utkesh. Utkesh, are you there? Yes.
Yes, sir.
Yes.
In normal condition, we cannot use AC to operate DC machine, but I think with some modification in the commutator, it is possible, sir.
Okay, good. So my next question to you. So what is the fundamental principle of the electrical machines? So suppose flux is constant. So as per the Faraday law, correct? So we can say the any electric machines that is operate on the based on the Faraday laws and Lenz law, correct? So Lenz is that is a negative
Yes,
sign of the d phi by dt, correct?
yes, sir.
But Faraday law, there is a voltage generated that is a proportional to the d phi by dt, correct?
Yes, yes,
So phi is nothing but flux, and t is nothing but time variation, correct?
yes, sir.
So is it possible? Suppose we can give the DC supply to the machine. So flux is a constant.
Yes, sir.
So is it possible to operate the any machine on the DC quantity?
I think yes, because it is not important that flux is variable. It is important in electromagnetic induction that the relative motion between two electric field and another what is uh, I think it is relative motions that makes the difference, sir.
Okay, good, very good. Yes, Suraj, are you there?
Yes, sir, I'm here, sir.
Okay, very good. So why there is AC and DC machines? So which one is first one motor? There is AC machine and DC machines.
Uh, Different, sir.
So which one is the first motor in the world? There is a DC machines or AC machines?
There is, I think, AC machine, sir. AC machine.
AC machines. Okay, good. So why then introduce the DC machines? What are the disadvantage of the AC machines?
DC machines are generally used in high torque requirement, like train. Train. We also use DC machine, as well as for constant torque as well as high torque requirement. DC machine is preferable than AC machine, sir.
But why? Why that thing? Why it is not possible in the AC machines?
AC machine, the main problem in AC machine, AC machine.
So everything is same, correct? Stator is there,
Yeah.
rotor is there, stator winding is there. Number of components are there, correct?
Yes, sir.
When we compare the AC machines and DC machines, only thing is the commutator is missing, correct? In
Commutator.
the AC.
Yes, sir.
Yes, only commutator is missing. Otherwise, everything is same, correct?
Yes, sir.
So because of the commutator, there is a only related to torque. So you said so torque is important parameter for the different application. I agree, but torque is related to your commutator. So because otherwise the all components are same.
Commutator is a magnetic converter, sir. Only rectifier,
Yeah, so
magnetic
magnetic converter. So we can say that is it a rectifier, correct?
rectifier. Yes, sir.
And rectifier is nothing but we can say the AC into DC, correct?
Yes, sir.
But
AC
in the
is
DC, yes, but in the DC machine we can give the DC supply. Then how commutator is work? Correct. So did you
yes.
observe the DC motor?
Yes, sir.
So we can give the DC supply, correct? Not the AC supply to the DC machine.
Yes, sir.
And we are
Requirement.
saying yes, and we are saying the commutator is nothing but mechanical rectifier, correct?
Correct, sir.
So rectifier is nothing but AC into DC.
Yes, sir.
But already we can give the DC supply. Then what they are converting?
They converting AC to DC, sir.
So from where we can get the AC?
The rotating part, the production of the AC is producer, so the commutator convert it into the DC, sir.
Okay, okay, good. Yes, last question to the Raj Saurav Gupta. Saurav, are you there?
Yes, sir.
Okay, good. So when you completed your BTech? Recently,
2018, sir.
2018. Okay,
5
5
years
years
back,
before.
sir.
Okay, let's see. Simple fundamental concept. So commutator is a steady state part or rotating part?
Commutator, sir, is a steady state part.
It's a
Carbon
steady
bros are
state part.
in rotating part.
Okay, so what is the difference between the commutator and carbon bros?
Sir, commutators are fixed on rotors and continuously connected with rotor bars or winding.
Okay.
But the carbon brushes are fixed on the stationary parts, which degrade or which reduces due to sparking and frictions.
Okay, last question to you. how many brushes and how many commutator segment is required for the any DC machines, and on what parameter it is depend. So
Sir,
we can say the commutator, there is a yes, you can continue.
the
Yes.
minimum we require two, but
So
for more is smoothness of conversion, we may require four, six eventually.
so that is you are saying the brushes, yeah, commutator.
Um, 1 second, sir. Commutator, sir. Process are fixed, sir.
So commutator required
Carbon brushes
minimum
we need
two.
only two. Commutators will be increased.
So commutator required minimum two, correct?
Yes, sir.
Because of positive and negative, that's why it is a two, correct?
Yes, sir. Yes.
And brushes,
Process two, sir.
maximum and minimum two.
Yes, sir.
Why only two? We can is it possible we can increase the number of brushes? Is it
No,
possible?
sir. I don't. I think, sir.
Okay.
Yes, sir. Only process should be only two. If you increase the process, then the current paths may be differ, sir.
Okay. Good. Good. So thank you so much. So let's see. We can start the fundamental thing. So I think you have sufficient knowledge about the DC machines. Yeah. So introduction about the machines. So we can say machine is a electromechanical device. So we already discussed this thing in the first unit that use the convert the electrical energy into the mechanical energy, otherwise vice versa. So we can say suppose we have a DC motor, then we can say electrical energy into the mechanical energy. And suppose we can say we have a DC generator, then we can say mechanical energy into the electrical energy. So we already discussed the detail about the fundamental principle of the machines in the first unit, correct? So according to the source of the supply, electrical machines are classified into two categories. Yes, there is a AC machine and DC machines. And machines again we can classify in the motor as well as the generator, correct? Okay. So DC machine that is used to convert the electrical energy into the mechanical energy, that is known as the DC motor. Yes, we can say supply, input supply for the DC machine, there is a DC supply. That's why we can say it is a DC machines, correct? So based on the supply voltage, we can classify the machines. Suppose your supply voltage is AC, then we can say the AC machines. Your supply input voltage is DC, then we can say the DC machines, correct? DC machine used to convert the mechanical energy into the electrical energy, known as a DC generator, correct? So in first line, there is your DC motor. So electrical energy into the mechanical energy, known as the DC motor. In DC generator, there is a mechanical energy into the electrical energy, correct? The same machine can be used either the motor as well as the generator, correct? Suppose you have a machine, suppose you have any machine, maybe the DC machine, yeah, AC machine, then we can use the same machine into the both, there is a generator as well as the motor. The construction is the same for the DC motor as well as the DC generator. Okay, so we can say the rotor and stator, everything same. So depend on your supply input, we can classify there is a machine as well as the generator. So working principle of the DC machines, working principle and the operation of the DC machines are based on the effect when current carrying conductor coil, yes, we can say the current carrying conductor coil put in the magnetic field, then it will generate the force, correct? So we can say current carry conductor coil lying in the magnetic field, yes, we can say the magnetic field. The magnetic field produces the mechanical force on it, known as a torque, which rotates the conductor coil in the magnetic field. So simple principle we can say whenever
Excuse me,
current
sir.
carrying conductor, yes,
I think presentation is not on, sir.
presentation is not visible.
Yes, sir.
What about now? Just a minute. Yes, now it's visible.
Yes, sir.
Okay, good, good, good. Okay, thank you so much. Yeah. So first slide, that is your introduction of the machines. So we can say machines classified the AC machines as well as DC machines. So based on the supply voltage, suppose AC supply, we can say AC machines. Suppose input supply voltage is DC, then we can say the DC machines. Correct? And again, machine is divided into two categories: this generator as well as the DC motor. So we can say DC motor, your input supply voltage, that is electrical energy, and output is a mechanical energy, then we can say it is a DC motor. Correct? And generator is just reverse. Input energy, that is your mechanical energy, into the electrical energy, then we can say electrical generator. Correct? Somebody want to join the class? Yes. 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 So, working principle of the DC machines. So, there is a simple working principle. We can say whenever current carrying conductor put in the magnetic field. So, there is a current carrying conductor. We have to put in the magnetic field. Then, magnetic field produce the mechanical force, and that force is nothing but your torque. Correct? And that is ultimately our target. We need to develop the torque, mechanical torque. Correct? And mechanical torque is nothing but your weight. How much weight you have to carry. So we can say electrical. So we can say electric vehicle. So there is a three-wheeler vehicle. We can say three passengers are there, and each passenger weight is a 50 kg. Correct? So we can say total 150 kilogram. Correct? So we can say 50 into 3. So total 150 kilogram. So we have to lift the 150 kilogram by the DC machines. Correct? And nowadays, everywhere there is a BLDC motor. So some student, beginning of the class, some student said that there is a BLDC motor, correct? BLDC, otherwise PMSM. So there is a brushless DC motor, otherwise a permanent magnet synchronous motor, correct? So ultimately it is required how much weight it is carry, correct? So there is a 150 kilogram, 200 kilogram, 500 kilogram. So that is ultimately torque. So our main target, we have to develop the mechanical torque, correct? So that's why we can design the different type of motor. BLDC motor, induction motor, DC motors, DC series, DC shunt, compound motor. There are various type of classification in the market, correct? So depend on the variety of the application, we can use the different type of machines. So you can see nowadays in the ceiling fan, we can use the BLDC motor, correct? But in the previously, we can use the induction motor, single phase induction motor, correct? But nowadays, all the market, all the industry people replacing induction motor with the BLDC motor because there are the so many advantage compared to the induction motor into the BLDC motor, correct? Yes, Fleming left hand rule we can use to find out the force direction, current direction, and the flux direction. So this thing we already discussed in the first class, correct? Yes, so whenever we design the machine, so there is a two role. One is a torque, how much torque is required, and second one is a speed, correct? So these two parameters are the most important factor while design the any type of machines. Maybe the AC machines, yeah, maybe the DC machines. So depend on the customer design, depend on the customer parameter specification, we have to design the motor, correct? But that parameter is only torque and the speed, correct? And third one, that is ultimately application, where we have to use this motor. Maybe the space application, maybe the train, maybe the crane, correct? So that is the most important part, correct? So we have to maintain the big size, maybe the small size, maybe the lightweight. Suppose in the satellite, correct? Suppose we have to use the motor in the satellite application. So that time, weight is the most important parameter. Amount is not important. Maybe amount we can increase 10,000 rupees to 20,000 rupees, but we cannot increase even 1 gram of the weight in the case of the satellite application, correct? So depend on the application, we have to use the motor, correct? In the case of the electric vehicle, correct? So amount is most important part, correct? We cannot increase the amount, maybe the 10,000 to 20,000. Yes, we can increase the weight. Suppose weight is a 10 kilogram to 15 kilogram. We can increase, not issue. But amount is a not increase. So that is a depend on the application. We can increase the size of the motor. We can increase the diameter of the motor. We can increase the efficiency of the motor. Correct? But this is a fundamental rule. Whenever current carrying conductor put in the magnetic field, it will create the force, and that force is nothing but your torque. Correct? So how much force will generate? So force is nothing but BIL. B, that is your flux density, Tesla. I, that is a current. Current is flowing in the conductor. And L is nothing but length of the conductor in the meter. Correct? So we can say force generated is equal to IL. Force F is nothing but magnitude of the generated force in the Newton. Correct? So this is a fundamental formula. That is the equation number 1. Generated force is nothing but B, how much flux, I, current, and the L, that is the length of the coil. Yes. Is there any confusion to anybody? Till now, any confusion? Okay. Yes. So Fleming left-hand rule and Fleming right-hand rule, we already discussed in the first class. So just this is the just revision and remind to you. Maybe the somebody missing the first unit. Okay. So we can say any machine that is operating under Fleming left-hand rule and right-hand rule, and why we can use this Fleming left-hand rule and right-hand rule, because of we have to identify the current direction, force direction, and flux direction. Correct? Then we have to use the Fleming left-hand rule and right-hand rule. Correct? Yes, John Ambrose Fleming developed these rules. There is a find out the direction of the current flux. Correct? In the 19th century. So this is just background of the Fleming. Correct? So Fleming is there is a scientist. Correct? It is important to note that this rule do not determine the magnitude. So this is the only the scalar quantity, not vector quantity. We can say scalar quantity, that is only we can identify the direction. It is not identify the magnitude. But the vector quantity we can identify the both magnitude as well as the direction. Correct? So Fleming rule is only applicable to find out the direction, not the magnitude. Okay. Instead of the showing only the direction, the 3 parameters, there is a magnetic field, current, and force. Okay, only 3 direction and 3 parameters. There is a field, magnetic field. Second is a current, and third one is a force. Correct? Yes, you can see this is the Fleming right-hand rule. So thumb, that is a motion. Otherwise, you can say the thirds. First finger, that is your magnetic field, and middle finger, that is we can say the current. Correct? So there is a Fleming right-hand rule. Okay. And Fleming left-hand rule, yes, thumb, that is a motion. First finger, there is a magnetic field, and second finger, there is a current. Okay. So Fleming left-hand rule we can use in the your motor case, and Fleming right-hand rule we can use in the generator case. Correct. Both parameters are same. Just we have one motor and one generator. Correct. Yes. So this is the most important slide. So you can see the construction of the DC machines. Major parts, commutator, that is the most important parameter. Okay, so you can see this is the commutator. So one of the students said, so we can use the minimum 2 commutator and maximum, that is a depend on the motor size and depend on the motor rating. Maybe the 1 kilowatt, maybe the 1 megawatt. Correct? That is a correct answer. But we cannot say minimum 2 because commutator is a segment. We can make a segment. Correct? So minimum segment, that is a 2, and maximum segment is depend on the size of the motor. Correct? Armature winding, armature, air gap, shaft. We can connect here load, any type of load we can connect through the shaft. Stator winding, stator, frame, outer side frame, so we can support the inner part. Carbon brushes, that is the most important part, and the cooling frame. Correct? So we can say these are the important parameters of the DC machines. Otherwise, we can see the important parts of the DC machines. Correct? Yes, yoke or frame. So DC machines consist of the yoke or frame, pole. Just one more minute. Student, it is my humble request, please join the class on time. Correct? So yoke or frame. So use of the frame, there is a support the inner part. Correct? So we can say commutator, stator winding, rotor winding. Correct? So we can provide the outer side support. So there is a environmental effect. Correct? Then pole, pole shoe, armature core, field winding, armature winding, commutator, brushes, shaft, and bearing. So these are the important parts of DC machines. Correct? Maybe the motor, otherwise maybe the generator. Correct? But these are the important parts. Correct? So you can see this is the field pole. So we can see the field winding in the DC machine. So this is you can see the different segment. Correct? This is commutator. Your frame. So you can see outer. So inner part is supported by the your frame. Correct? So we can say it is a frame. Armature. So we can say the rotor winding. That is your armature. Okay. But in the case the induction motor, there is a just reverse. Your stator winding, there is armature winding, and rotor winding, there is a field winding. Correct? But in the case of DC machine, just reverse. Correct? Field winding, there is your stator winding. Correct? Pole shoe and shaft. Okay, so this is the major parts of the DC machines. So one by one discussion. So yoke and frame. So it is cover the internal part of the machine. As I said in the previous slide, so role of the yoke and frame, it is nothing but we have to support the protect. We have to provide the protection of the inner part. That is the pole shoes, brushes, commutator, stator winding, rotor winding. The yoke is made of the low reluctance magnetic materials. So this one is most important part. Your frame, it designed by the low reluctance magnetic material, so we can supply the maximum flux. Correct? Like iron or silicon steel. Generally, the yoke is made up of the iron because iron cost is effective material than the steel. Yoke is used to provide the mechanical protection to the machines. Yes, it is ultimately provide the mechanical protection. The second application of the yoke is that provide the low reluctance path to the flux. So that flux complete the path to the yoke. Yes, that is a low reluctance is the most important part. So we can provide the maximum flux. Okay. What is the use of the pole and pole shoe? So field winding is placed on the pole. Yes, we can say yes, this is your pole. Correct? So we can say yes, this is the your winding. So we can say field winding, otherwise the armature winding. Correct? So field winding placed on the pole. When the current pass through the field winding, it will create the electric magnetic field and behave as an electromagnet. Pole shoe expand the flux in the entire machine. Yes, what is the shape of the pole shoe? It is something like that. Something like that. So we can take maximum flux, something like that, correct? So we can take maximum flux from the pole shoe. So this shape is nothing but pole shoe, correct? Okay. Reduce the eddy current losses, the pole and pole shoes are limited. We have to reduce the losses, eddy current losses, IS spiral losses, hysteresis losses, many losses we have to reduce. So that's why we have to design the specific shape of the pole shoe. And also we have to provide the lamination, correct? For the small machine, the poles is not necessary to laminate. It is made of the thin cast steel. Yes, suppose it's a very small machine, so it's not laminated. So we can say it is yes in the DC, in the most of the toys, we use the DC machines. So there is a very small rating. Then the lamination is not required. But we can use thin cast steel material to reduce the eddy current losses. The pole is used to provide the housing for the field winding and produce magnetic flux inside the machines. The poles are used to provide the support to the field winding and not slip from the pole. So this is the most important thing. So pole shoes are used to provide the support to the field winding and not slip from the pole. Yes, that is the most important. Field winding. So it is a winding wounded on the pole, which is known as the field winding. External DC source or the output of the machine is used to excite the field winding. It is made of the copper or aluminum, but 99% is a copper. In the most case, winding is made up of the copper, but when the cost is considered, aluminum is used. Yes, we can say the 1 to 2%. While cost is the most important factor, then we can use the aluminum. Otherwise, 99% we can use the copper. When DC current passes to the coil, it will generate the electromagnetic field. And it will magnetize the pole and produce the magnetic flux. That is simple. The flux is produced by the pole. It is directly proportional to the field current. Okay. Armature core. So there is your field winding. So we can say stator winding, and armature core, there is your rotor part. Correct. So armature core shape connected by the key of the shaft. Yes, whenever we can say shaft, that is nothing but your rotor. Correct. So it is a rotating part of the DC machine. Yes, student, please remember, whenever we can say field winding, there is a stator part. Whenever we can say armature winding, there is your rotor part. In the case of the DC machines. But in the case of the AC machine, just reverse. Armature, that is your stator, and field, that is your rotor. Correct? Armature consists of the number of slots on its outer periphery. It is made up of the low reluctance and high permeability material like cast iron or the cast steel. Armature coil is laminated to reduce the eddy current losses. Same like field winding, we have to laminate it. So here is also armature core, we have to laminate it, correct, to reduce the eddy current losses. Yes, so you can see the armature construction, carbon brushes. So use of the carbon brushes to collect current. So what is the use of carbon brushes? To use of the carbon brushes, we have to collect the current. Okay. From where we have to collect the current? From the commutator. Correct. So you can see the commutator bar. 1, 2, 3, 4, 5, 6, 7, 8. Correct. So depend on the machine's application, depend on the power rating, we can use the number of bars. But minimum is a 2. Correct. And this is your armature, correct? And this is your bearing. Of course, bearing is most important part, otherwise motor is not able to rotate, correct? So for the provide the friction, we can use the bearing. Okay. Yes. In the case of the DC machines, armature winding is two type. One is the first one, there is a lap winding, and second one is a wave winding. Okay. Lap winding and the wave winding. So what is the difference between the lap and wave winding? So there is a number of armature windings. So we can say lap winding. Lap winding equal to P. Okay. So armature coil is equal to number of pole. P, that is your number of pole. Correct? Yes. P is equal to number of pole. But in the case of the wave winding, what is the A? Any idea? In the case of the lap winding, we can consider the A equal to P. Correct?
Half.
But what about the A?
A equal to 2.
Half
So,
A equal to 2, correct?
P by
Yes,
2.
A equal to 2. Otherwise, P by 2. Correct?
Yes, sir.
Both are correct. Otherwise, the A equal to 2, otherwise the P by 2. Correct? So, this is the most important part. So, this will helpful in the numerical. So, maybe you will get the one numerical for the DC machines, and there is a basically based on the lap winding and wave winding, and you have to find out the torque, speed, and maybe the sometime flux, correct? And maybe the winding is a lap winding, maybe the wave winding. Then you have to identify the suppose wave winding, then A equal to 2, yeah, A equal to P by 2. And suppose lap winding, then A equal to P, correct? Yes. Why two type of winding? So there is a depend on the power rating.
Excuse me, sir.
Yes.
Commutator is fixed on rotor, or it is rotating part, sir?
So it is a fix on the rotor.
Fixed on the, yes, sir.
Yeah. So you can see this diagram. So this is the fix on the rotor. Correct?
Okay, sir. Okay.
But in the sometime there is a also rotate with the rotor. There is a depend on the application where we are using the DC machines. But most of the time, there is a brushes are fixed and commutator is rotating with the rotor. Correct? But some application, your brushes is rotating and commutator is fixed. Correct? So that depend on the application, we can make the construction of the commutator and as well as the brushes. But role of the brush is to collect the current from the commutator, because commutator is produced sometime for the half cycle there is a positive and half cycle is a negative. Correct? So there is a change in the direction. Okay, and for the brushes they have to collect the current from the commutator. Okay. Yes. So lap winding, in the lap winding, the armature conductor are divided into the group of the number of pole. Yes, we can say lap winding is nothing but A equal to P. Correct? All the conductor group are connected in the parallel, and the one group, all the conductors are connected in the series. Correct? So maybe the sometime all the conductor connected in the series, yeah, maybe the sometime all the conductor connected in the parallel. So depend on the torque requirement, correct? So we can say torque is directly proportional to the current. And whenever we put the coil in series and parallel, then that relation you know very well, correct? Suppose you want to increase the number of, suppose you want to increase the current rating, then you can connect the parallel. Suppose you want to increase the voltage rating, then you can increase in the series, correct? So that depend on the specification, we need to connect the series and parallel combination. For the lap winding, the number of parallel path, that is A, is same as the number of pole. Yes, same relation, that is A equal to P. Therefore, lap winding, the number of parallel path is more, and due to this, it is capable to supply the large load current. So that's why we have a two winding. One is a lap winding and second one is a wave winding. So this one is most important, and due to this, it is capable to supply the large load current because of the parallel path. Correct? Because of the parallel path, it will provide the more current, and more current, then obvious that is a more load torque because of this relation. So lap winding is used for the low voltage and high current application. Yes, low voltage because of the parallel connection. Suppose is series connection, then the high voltage, but here is a parallel connection, so we can say the high current. Okay, in the high current application. What about the wave winding? Wave winding, all the conductors are connected in the series and it is form of the single loop. Yes, this is wave winding. Suppose it is required the more speed because series connection, correct? Voltage is directly proportional to the speed. Correct? Okay. And speed, suppose you want to more speed, then we can say yes, it is a wave winding. So wave winding, all the conductor are connected in series and it is formed the single loop. For the wave winding, irrespective of the number of pole, the number of parallel path is always 2. Okay. Yes, minimum we require the 2. Correct. So in the wave winding, smaller number of parallel paths are available compared to the lap winding. The wave winding is used for the high voltage and low current DC machine. Yes, maybe I will ask in the Viva, what is the difference between the wave winding and lap winding, and where we can use the lap winding and wave winding, correct? So simple answer is wave winding, that is your series connection, and whenever we can say series connection, there is a high voltage. High voltage means there is a high speed. So we can say wave winding is used for high voltage and low current DC machines. But lap winding, we can use the low voltage and high current application. Correct? So both are the vice versa. Yes, this commutator.
Excuse me, sir.
Yes.
Is there any other method to remember this point, sir? This high
Can you just
voltage
repeat?
and is there any other things so that we can remember this point?
Your voice is not clear.
I will write, sir. Okay.
Your voice is not clear. Maybe you can type in the message. Yes, Sanjivas is number of commutator segment depend on the number of. Yes. Yes. Am I audible? Yes. Okay. So yes, कोई student ask question पूछ रहा था. Somebody asking the some question. So can you just repeat your question? Yes, Saurav. Yes. Yes, sir. To do.
No, sir, I
If
don't have any questions.
okay. Maybe my internet issue here is internet issue. Okay. So just 1 minute. Yes, Uskes asking something. Sir, my question was, is there any other method to remember the voltage and current point of the lap and wave winding? Utkesh, from my knowledge, I think no, but maybe you can figure out some other way. But simple concept is wave winding, there is a series and parallel combination. But maybe you can find out the any other way. But as of now, I don't know. Okay. Yes. So my presentation is visible to everyone? Yes, Sanjeev.
Yes, sir.
Okay. Yes. So commutator is mounted on the shaft of the machines. Yes, we can say there is a rotor, correct? So shaft is nothing but rotor. Armature conductors are rotating. Yes, because rotor is rotating, so armature conductor is rotating. Yes. Commutator is used to connect the rotating armature conductor with a stationary external circuit. Okay, so commutator is used to connect the rotating armature conductor with a stationary external circuit. It is convert the alternate torque produced in the armature into the unidirectional torque. Okay, so we can say it is a converter. Commutator is nothing but mechanical converter. Okay. In the other word, it convert AC torque into the DC torque. Otherwise, we can say it is a rectifier. Correct? So in the electrical circuit, we can say rectifier. What is a rectifier use? So it is a AC into DC. Correct? So convert AC torque into the DC. So it works as a simple to the rectifier. Correct? It made up of the number of segment of hard drawn copper to reduce the tear and wear. So there are the many segments. So we can say this is the commutator. So we can say yes, many segment. Segment 1, segment 2, segment 3, 4, 5, 6, 7, 8. Many segments are there. So depend on the power rating. So there are segment, correct? But commutator is the most important factor, correct? So I will give the one question is a assignment. So I will write the question and then I will send this question to the Sanjeev, correct? So you have to write the answer on the commutator, because commutator that is the most important factor in the DC machine. Otherwise, all the parameters are them same in the AC machine, otherwise the DC machine. Only difference is a commutator. So you have to focus on the commutator. How commutator is work? What is the role of commutator? Because we are giving the AC DC supply to the motor, and again we are saying it is a converted into the AC, correct? So convert AC torque into DC torque, correct? So ultimately we are giving the DC supply. So why again we have to convert it to DC supply, correct? Brushes. So brushes are used to carry the current from the armature conductor. Yes, we can say the collect the current from the armature. Otherwise, we can say the commutator. In the most cases, brushes are made up of the carbon or the small machines, electrographic brushes. Most of the time, that is a carbon brushes. Otherwise, the electrographic brushes are used in the large machines. For the small machine, that is like carbon brushes, and large machine, that is a electrographic. Brushes are held on the surface of the commutator by springs and are rectangular in the shape. Yes, in the previous slide, I shown you that is a brushes. Yes, so this is the brushes, correct? And there is a carbon brushes. Shaft is nothing but we can say the mechanical power. We can collect the mechanical power to the shaft. If the machine is used as a DC motor, mechanical power is transferred from the motor to load. So that is simple. We can use the shaft to connect any external load. Correct? Yes, bearing. What is the role of the bearing? So bearing are used to end of the shaft. Yes, so there is a mechanical friction. It is provide the mechanical friction. The friction between the rotating part and the stationary part is reduced with the help of the bearing. Yes, without bearing, how we can say motor is rotated and we can connect the load, correct? Yes, without the bearing, we can say motor is rotated, but while we connect the load with the shaft, then bearing is a necessary component. Bearing is made up of the any hard material like carbon steel. Mostly we use the carbon steel to make the bearing. Ball type or roll type bearing is used in the DC machine. Yes, there are the many type of bearing, but normally we use the ball type and roll type bearing. Okay, and what is the meaning of ball type and roll type? It is not the part of our electrical engineering. It is a part of the mechanical side. Okay, so don't worry about the type of the bearing. So just remember, so we can use the ball type, otherwise the roll type bearing. Okay. Yes. So till now we cover the parts of the DC machines. Now classification. So just we can classify the motor, that is a DC machines, series machine, shunt machine, short shunt compound machine, and long shunt compound machine. Okay, so there is a type of DC machine, and according to the field of excitation, separately excited and the self-excited DC machines. Okay, so mathematical analysis we will study in the next class, but in this class, just overview of the series machine, shunt machine, short shunt compound, long shunt compound, and separately excited and self-excited DC machines. Okay. So, what is the meaning of separately excited DC machines? So, we can say both are separate. There is a field winding is separate and armature winding is separate. Then we can say the separately excited DC machine. Name is suggests it is a separately, correct? So, you can see field winding is separate and armature winding is separate. Both are different. Then we can say separately excited DC machine. So, there are no physical connection between the field winding and armature winding. In separately excited machine, the field winding is supplied from the separate power source. Yes, both are supplied by the separate. Because there is no connection, physical connection, then we have to give the both separate power supply. Correct? So this is my last slide. From the next class, we will study the elementary of the two-pole DC machines. So we will study the mathematical relationship. Correct. So you can see this is the two-pole machine. So pole number 1 and pole number 2, and you can see this is the commutator. Correct. We can say brushes, and motor is rotating anti-clockwise direction. Field winding. Correct. So this is the cross and this is the dot. What is the meaning of cross and dot in the case of the stator winding or rotor winding? Any idea? So here is a cross. You can see this is the cross and here is a dot. Any idea to anybody? What is the meaning of cross?
Current in or current out, probably.
Okay. So yes, that is a correct. But current cross means current in or current out?
Current in, sir.
Current in. And dot means
Current out.
current out. Yeah, that is a correct. So suppose you will become the design expert, so that this thing is most important. So cross, that is a current in, and dot, that is a current out. So you can see this here is symbol cross and dot. Okay, so current entering from the F1 and current out from the F1 dash. So this is the equivalent circuit. So we can set the supply voltage, so field voltage, okay, armature voltage, and these both are these are the separately excited motor. So you can see the F1 dash, F2 dash, because the two pole. So first winding and second winding. First winding input and output, second winding input and output. So this one is the equivalent circuit. Equivalent circuit of two-pole DC machines. Correct? So detail
Screen is not
explains.
visible, sir.
Sorry,
Screen is not visible, sir.
screen is not visible.
Yes, sir.
Just 1 minute. Now is visible?
Not, sir. Still, it is not so.
To everybody,
Yes,
It's
it is visible
visible,
right
sir.
now, sir. Right now, it is visible, sir.
Visible, sir.
right now is visible, correct? Okay. Yeah, so this one is basically the element of the two-pole DC machine. So anyhow, we will discuss the detailed mathematical analysis in the next class. But this is just for your knowledge. So what we will study in the next class. Okay, so we can consider the simple two-pole machine, and there is a simple machines. Minimum two-pole is required to design the any machines. Okay, pole number 1 and pole number 2. And we have a cross and dot symbol. So cross means there is a current in, and dot means current out. Okay, and then we can say yes, field winding incoming current, and here is outgoing current. Second pole incoming current and outgoing current, and this is the equivalent circuit. Okay, so this one is figure 1, equivalent circuit. So this is the your field winding, and this is the armature winding. We have to supply the both side because this is separately excited machine, correct? So in the next class, we will see the detailed mathematical relationship. There is a supply voltage, field flux, speed, torque, okay? So from the next class, we will see the elementary of the two-pole DC machines. So key point from the today's class, introduction of the DC machines, theory of the DC machines, classification of the DC machine, and the model of the commutator. Okay. Yes. So one assignment on only one question. So you have to write the working principle of the commutator. Okay. Working principle of the commutator. Okay, working principle of the commutator with diagram. Okay, and step by step process. Because this is the most important factor, how commutator is used in the DC machines, correct? So first you have to tell there is a difference between the AC and DC machines, maybe the 1 to 2 line, and then you have to write detail about the commutator, correct? So working principle of commutator with the diagram, correct? And then step by step explanation, how they are converting AC power into DC power. Because we are saying there is a rectifier, correct? And rectifier is nothing but AC into DC. Because we are giving the DC supply to the DC motor. But how they are converting the DC into AC and then again DC AC into DC, correct? So you have to explain everything. Maybe in the Word file, maybe you can use your A4 page. You can write by your handwriting, correct? Anything. But you have to submit the one assignment and only one question, and then working principle of the commutator. And you have to cover minimum requirement of the commutator. Minimum requirement of commutator. Correct? And second one, relation of the brushes. Brushes with commutator. Is there any relation? Suppose I can say, yes, I have a 2 commutator segment, then how many brushes are required? So is there any direct relation with the commutator and brushes? Yeah, we can choose randomly. Suppose my commutator segment is maybe the 10, correct? So maybe I can use the only 2 brushes. Is it possible? Yes or no, correct? So you have to cover this thing in the assignment. So now you have a 2 assignment. First one, that is a MATLAB, simple RLC circuit. Second assignment, that is your a question. Working principle of commutator with a diagram and step-by-step process. Minimum requirement of commutator and relationship between the brushes and the commutator. Okay. So from the next class, we will see the elementary of the 2-pole DC machine, and there is a totally mathematical analysis. So suppose we have a 2-pole DC machines, then what is the relation between the voltage, current, flux, and the we can say the mechanical power. Okay. Yes. Any confusion, any query from the today's class? Yes, student. Yes, student. Any confusion, any query? Okay. No query, then we can stop the today's class here, and please complete your MATLAB assignment first, and then this assignment, that is second assignment, and that is the commutator part. Okay. So this commutator part, maybe you can use the Word file, yeah, maybe A4 size, correct? Ultimately, you have to submit the soft copy. Suppose you are writing in the A4 page, then you can just scan that pages and then email me, correct? Okay, if you know query, then we can close the today's class. Okay, thank you so much. So we will meet on the Wednesday.